Today, we're going to zoom way in to tell a story of invasion, a heroic defense, and a massive cleanup operation. It's a battle that happens inside you all the time, and it can be triggered by something as tiny as a splinter. Of course you have. You get that tiny piece of wood stuck, and you see the redness, you feel it throbbing, but what's really going on under your skin? Well, that whole process, that's acute inflammation. It's your body's elite first response team, and they are springing into action. You know, we often think inflammation is a bad word, right? But in this story, it's actually the hero. It's a totally natural protective response that's super fast, short-lived, and absolutely essential for healing. It's basically your body saying, "Don't worry, I got this." So what's the point of all this trauma? I mean, what's this process even trying to do? It's not just a random freakout, oh no. It's a highly coordinated mission with some very specific goals. Think of this as the body's four-part mission plan. Step 1, take out the bad guys, any bacteria that hitched a ride on that splinter. Step 2, lock down the area, create a perimeter so the trouble doesn't spread. Step 3, clear the battlefield of any damaged cells. And finally, Step 4, call in the construction crew to start the repairs. Just a brilliant 4-step strategy. So if this whole battle is going on inside, how do we even know what's happening? Well, it sends out some pretty obvious clues to the outside world. These are the classic, telltale signs that let you know your body's defense system is on the job. And here they are. I bet you felt every single one of them. You've got the redness, the heat, the swelling that makes your finger look all puffy, and of course, the pain that just screams, "Hey, don't touch me." Each one of these signs is a chapter in our microscopic story. Okay, so what's up with the redness and heat? Well, as soon as you get that splinter, your body releases chemicals that cause the local blood vessels to get wider. It's a process called vasodilation. Think of it like this. Your body instantly turns a 2-lane country road into a 6-lane superhighway to rush emergency services to the scene. All that extra blood flowing in makes the area look red and feel warm. Simple as that. Now, at the same time, the walls of that superhighway, the blood vessel linings, they become, well, leaky, more permeable. This lets all this protein-rich fluid and, more importantly, defense cells escape the highway and flood into the tissue where the splinter is. That fluid buildup is what we call edema, and that's exactly why the whole area swells up. And the pain? Why does it hurt so much? That is your body's alarm system, plain and simple. Those same chemicals from the injury trigger all the nearby nerve endings, sending a big, loud signal right to your brain that says, "Warning, we have a problem here. Protect this area at all costs." Okay, so the scene is set. The alarm is blaring. Now it's time to call in the ground troops. We're talking about specialized white blood cells, and the very first ones to arrive are the neutrophils. These guys are the special forces, the Navy SEALs of your immune system. But, you know, getting from the bloodstream to the actual splinter, it isn't easy. It takes this incredible 3-step journey. First, they have to stick to the blood vessel wall. Then they have to literally squeeze through it. And finally, they have to follow a chemical trail to get to the exact spot where the trouble is. It's so cool how they manage to stop in the fast-flowing traffic of your bloodstream. First, the slowing blood flow pushes them over to the edges, to the shoulder of the highway. Then they start to kind of roll along the vessel wall, making these weak, temporary connections. And then, bam! Stronger proteins lock on, bringing the cell to a dead stop right by the exit ramp. So once they've squeezed their way out of the blood vessel, how on earth do they know where to go? Chemotaxis. It's like they're following a trail of chemical breadcrumbs left behind by the bacteria and your own damaged cells. This system guides them with pinpoint accuracy, like a microscopic GPS, straight to the splinter. All right, the troops have arrived. They've reached the battlefield. They're surrounding the splinter and all the bacteria it brought along for the ride. Now, it's time for the cleanup crew to get to work. But they don't just start blasting away at everything. No, first they gotta recognize the enemy. Neutrophils have these special receptors on their surface that are designed to identify molecules that are only found on bacteria. It's like a secret handshake, and once they get that handshake, it triggers their activation. It's go time. And this is the final showdown. It's called phagocytosis, which literally means cell eating. The neutrophil reaches out and engulfs the bacterium, trapping it in this little internal bubble. Then that bubble fuses with another pouch that's just filled with destructive enzymes. These enzymes, along with other toxic chemicals, just completely dismantle the invader. And the harmless leftovers get spit back out, enemy eliminated. So,
The splinter is out, the bacteria are gone, the immediate threat has been neutralized. Mission accomplished. But, and this is a huge but, a really key part of this whole process is knowing when to stop. You can't just let the special forces run wild forever, right? Luckily, the inflammatory response has several built-in off switches. For one, the reason for the fight, the splinter, is gone. The chemical messengers that sounded the alarm, they have really short half-lives, so they just fade away. The neutrophils themselves don't live very long. And finally, the body releases a whole new wave of anti-inflammatory signals to calm everything down and officially end the emergency.
Okay, one last really important detail. Remember that fluid that caused all the swelling? In our splinter story, that fluid is called exudate, and it's very different from another type of fluid buildup called transudate. As you can see here, exudate is thick, it's rich in protein, and it's jam-packed with cells and debris. It's basically the soupy aftermath of the battle. Transudate, on the other hand, is thin and watery. This is a super important distinction for doctors when they're trying to figure out what's causing swelling somewhere in the body.
So, from one tiny little splinter, we get to see this incredibly powerful, precise, and protective system go to work. It's a response that is designed to be fast, furious, and temporary. But that leaves us with a pretty critical question. What happens when this system, this amazing system designed to protect us, never gets the signal to stand down? What happens when the battle never, ever ends? Well, that's when things can get really complicated.